Hello everyone, welcome to Tuteetute. In this session, we will see all the previous year questions from the GENCO, TRANSCO and SPDCL, NPDCL and some of the questions from EPDCL also. So these are all comes under the Telangana state and Andhra Pradesh state. Okay, so electrical AE exam questions. Okay, so let's see the questions now. So the first question, the power system is subjected to a fault which makes the zero sequence component of current equal to 0. The nature of the fault is, okay. So they have given one condition, only one condition, the zero sequence current IA naught is equals to 0. Okay, so remember only one thing, okay. So when zero sequence current will be present means wherever ground present, then only, so there will be zero sequence current, okay. So remember some point, okay. So that is nothing but, so wherever ground present, okay, so ground present, see in any some fault, okay, so in any some fault, if ground present, then only zero sequence current will present, okay. So then only zero sequence current, IA naught or IB naught or IC naught, anything is zero sequence current only, okay. So IA naught present. Otherwise, if ground not present, then IA naught not present, or zero sequence current not present, okay. So that's why, so see the options, okay. Double line to ground fault, that means LLG fault, okay. So double line fault, LL fault. Line to ground fault, LG fault. Three phase to ground fault, okay. That means triple LG fault, or triple LG fault is a symmetrical fault and it is equivalent to triple L fault also. Okay, triple L fault or triple LG fault, same analysis only, okay. So that's why you see the options, okay. From the options, wherever in the fault ground is present, then definitely zero sequence current is present. If ground is not present, where the ground is not present, in line to line fault, okay. So in line to line, wherever three phase lines are there, A phase, B phase, C phase, if line to line fault is there, there is no ground involvement, okay. For example, if it is LG fault, so ground involvement will be there, okay. So this is line, this is ground, okay. So that means wherever LG fault or LLG fault is there, definitely IA naught component will be present, okay. If ground is not present like this, then only, so zero sequence current will not be present, okay. So answer for this question is B. Next question, okay. The operator A rotates the vector in anti-clockwise direction by, okay. So this is, so A means it is a component, okay. So component, what component it is means in power system analysis, okay. So in power system analysis, during the fault analysis and per unit, okay. So we will be giving the parameter A or K or alpha like this, anything is same thing only, okay. So anything is same. So A is nothing but 1 at an angle of 120 degrees, or K is nothing but 1 at an angle of 120 degrees, or alpha is nothing but 1 at an angle of 120 degrees, okay. So this is the one, okay. So in some textbooks they have represented as A, in some textbooks they will represent as alpha, in some they will follow K, okay. So anything is same only. It will rotate the vector in anti-clockwise always at 120 degree only, okay. So answer for this question, all the vectors rotates in anti-clockwise direction, okay. So this is A, okay. So and this is the A means, what is the value of A means 1 at an angle of 120 degree, okay. If you want, you can give the value also, cos 120 plus, okay. So J sin 120, so this is the value, okay. So if you want to represent in terms of A plus JB form, okay, this is A plus JB form, okay. If you take the magnitude, you will get 1, and what is the angle means, that is 120 degree, okay. So anyway, A this is, and after that 120 degree, okay. So next, after A what will come, so this A 120 is there, right, okay. After 120 degree, A square will come, okay. So A square means, this is A square means square of this 1 at an angle of 240 degree, okay. So A cube means, that is nothing but 1 at an angle of 360 degree, okay. So this is A square and another one is A cube, okay. So what is the angle difference means, 120 degree, and here obviously it is 120 degree, okay. So like this, all the three vectors will rotate, and this operator will rotate 120 degree in anti-clockwise direction. Answer for this question is 120 degree. Okay, so next question, find the value of A power 729 where A is an operator, okay. So the same type of question it is. So they are just asking about the operator A, okay. What is the value of A? A is nothing but 1 at an angle of 120 degree. So what they have asked, A whole power 729 they were asking. Okay, so a power 729 they are asking. So anyway, let's check. Okay, so what is a square value? Okay, 1 at an angle of 240 degree. Okay, so a cube, what is a cube value? 1 at an angle of 360 degree. Just now we have seen this. Okay, so 360 degree means, so obviously 0 degree only, right? Okay, so 360 degree is equals to 0 degree only. So you can write down this one as, okay, so 1 at an angle of 0 degree. So a cube value is nothing but 1. Okay, remember a cube value is equals to 1 means directly here how many a cubes are there? You can write down this one as, okay, let's calculate. 729 divided by 3 I will calculate. So 3 ones, 3 twos and 3 fours. Okay, so this is 3 threes. 243 3 times. Okay, so I can write down this one as a cube whole power 243. I can write down like this, right? Okay, so that means a cube value equal to 1 means 1 whole power 243, that will be equal to 1, right? Obviously. Okay, so what is the answer for this question? Find the value of a power 729, right, where a is an operator. Answer for this question is 1. Okay, if they ask a power 728, what is the value means? Directly you can calculate. Okay, so a power 720, okay, so 726 we can calculate. Okay, a power 726 into a square we can write down, right? This value is obviously it is 1 and this is a square. Okay, so you can write down like that. Okay, so wherever whenever this model of questions are coming, okay, so just check, okay, so whether it is divisible by 3 or not. Okay, so answer for this question is 1. Okay, next question. The impedance value of a generator is 0.2 per unit on a base value of 11 kV 50 MVA. The impedance value of a value for a base value of 22 kV 150 MVA is. Okay, so what is the question they have asked? The impedance value they have given in terms of per unit. Okay, Z per unit is equals to 0.2. That's what they have given. Okay, so 0.2 they have given. So I am taking these are the old values. Okay, old values where this Z per unit is calculated based on the base value of 11 kV and 50 MVA. Okay, so I am calling these things are old base. Okay, so old base. You know these questions are from power system analysis. Okay, this is the previous year questions. All these things. Okay, SPDCL or NPDCL, GENCO TRANSCO, or we have all the previous year questions. Okay, so from the only Telangana and Andhra Pradesh state, and these are the same model of questions will come in the other PSU exams also. Okay, same model of questions. Okay, this is old base. Okay, now what they are asking, if the base value is changing to the new base, what is the new base? 22 kV 50 MVA. Okay, so 22 kV 50 MVA 150 MVA. Okay, so 150 MVA. So what is the value of impedance? That's what they are asking. Okay, so Z per unit new they are asking. If this is old value, what is the new value they are asking? Okay, so this is new base. Okay, so this is new base. Okay, so we have directly one formula. Okay, so Z per unit new we can calculate. Okay, this is very important formula. Okay, so definitely there may be some question. Okay, so in every 2 years, in every 2 exams, so there will be one question like in this model. Okay, so not only in our exam. Okay, so even in the engineering services, so definitely they will ask this model of question. Okay, Z per unit new equal to Z per unit old into, so this is the formula. Okay, just directly remember, otherwise you can derive this one within seconds only. Okay, so MVA new divided by MVA old into KV old divided by KV new whole square. Okay, so this is the formula, we just need to substitute. Okay, that's it. What is Z per unit old? Okay, so it is 0.2. What is the MVA new? 150. What is the MVA old? 50. Okay, 150 divided by 50. Okay, so both are in MVA only, no need to change anything. Okay, KV old value is this thing. Okay, this is the new value. Okay, so 11 kV divided by 22 kV. Okay, so 11 by 22 I am writing, so both are in kV only. Okay, no problem. So 11 by 22 whole squares. Okay, if you calculate you will get Z per unit new is equals to 0.2 into 3 into 1 by 2 whole square, that means 1 by 4. Okay, so if you multiply, you will get 0.6 divided by 4, that will be equal to 0.15. Okay, 0.15 per unit. Okay, so per unit only. Okay, answer for this question is option C. Okay, next question. At slack bus, which one of the following combinations of variables are specified? Okay, so this is the question from the load flow analysis. Okay, so from the load flow analysis, so from that, okay, so you can see there are buses, right? Different type of buses. What are the buses? Buses are nothing but the nodes in a power system network. Okay, so we have to categorize the buses. If the bus is load bus, what is the fixed values? What are the variable values? Okay, we have to give like that. Okay, so let's see what are the different type of buses. Basic buses we have. Okay, so the buses are load bus. Okay, otherwise first we will take generator bus. Okay, so first one is generator bus, which is also called as PV bus. Okay, so remember this one only. Okay, so PV bus, if you remember, what are the values specified? Okay, so specified values. Okay, you can see P and V are specified. Okay, so P, active power and voltage. Okay, so active power and voltage. You see, for any of the generator, how much is the rating of that one? Okay, how much it is generating? Okay, active power rating they will be giving. Okay, and similarly voltage also we will be giving. Okay, so what is the voltage it will be producing? Understood, right? For any of the generator bus, specified values are these things. Okay, so next bus is nothing but so another one is load bus. Okay, so load bus. Okay, so load bus is also called as a PQ bus. Okay, PQ bus. PQ bus means for any load, how much active power it will take, how much reactive power it will take. Okay, we will be knowing those things, right? Okay, that's why. So P comma Q are specified values for any of the load, how much active power, how much reactive power it will take. Okay, so it will be known for us. That's why these are specified values. Okay, now next one is a slack bus. Okay, slack bus. Slack bus is also called as a reference bus. Okay, so reference bus. Slack bus is nothing but reference bus. Okay, so at the reference bus, what are the specified values means the voltage will be specified, and similarly angle delta, rotor angle or stability angle we will call. So this angle is specified. Okay, so these are the three things. Okay, so these are for the reference bus or the slack bus. If these are the specified values which are not specified, what are the not specified things? Okay, so not specified. Okay, we have to just check. Okay, so what are the parameters for any of the bus? Active power, reactive power and voltage and delta. Only these four we need to check at each and every bus to understand about that load. Okay, so to understand about all the loads at each and every bus you need to understand about these four parameters. Okay, so that's why if these two are specified, what are the not specified ones? Remaining two, this is nothing but Q comma V. Okay, so these two. And for the load bus, what are the not specified ones? Okay, voltage and delta. Slack bus, what are the not specified ones? Active power and reactive power. Okay, so these two are not specified. Okay, so generally these are also magnitudes only. Okay, so magnitudes. Understanding, right? Okay, so these are not specified, these are specified. From the question, at a slack bus, which one of the following combination of variables are specified? Okay, so what are the specified ones? So voltage, magnitude and delta. Voltage, magnitude and delta. That is the answer for this question. Okay, next question. Which one of the following statement is normally correct for a Z bus matrix? Okay, so remember this one. So there are different analysis, right? To understand about power system network, we can do Z bus analysis or Y bus analysis. Okay, so whenever you do the Z bus analysis or Y bus analysis, you will be giving the equations to the voltage to the current. That's it. Voltage to current, you have to give the equations. What are these equations? It is nothing but the KVL and KCL equations only. Understanding, right? So whenever you are giving like this, you will be represented in terms of matrix. Okay, which matrix you can represent? Either Z bus or Y bus you have to represent. Okay, so that's why, so if it is a Z bus representation, okay, so Z bus matrix, how it will be means, Z bus matrix is full matrix. Okay, full matrix. Why it is full matrix means, see, for every transmission line, okay, there will be some impedance between two buses. If any line is there means definitely there will be some impedance coming. Understanding, right? So from this bus to the 100th bus directly there is no transmission line, but from here to there will be some impedance. Understanding, right? So that's why Z bus matrix is not at all any zeros will be present. Okay, no zeros will be present, or very less zeros will be present in the Z bus matrix. That's why it is a full matrix. Whereas if you take the Y bus matrix, okay, Y bus matrix, so generally Y bus matrix will be, Y bus matrix means we will be representing the admittances. Okay, so from the bus to bus we will represent the admittances. Okay, we will see how to make the Z bus matrix and how to give the Y bus matrix also in some other questions. Okay, so maybe in this session or in next session. Okay, so Y bus matrix, so it is sparse matrix. Okay, so sparse matrix. What is a sparse matrix means? Many zeros will be there, okay, or empty. Okay, so empty, it means empty. So more zeros are present means that type of matrix is called sparse matrix. Okay, so that is Y bus matrix. This is also important bit only. Okay, so anyway this question they have asked about Z bus only, but they may ask about Y bus also. Okay, so which one of the following statement is normally correct for a Z bus matrix? Okay, so Z bus matrix means null matrix. Null matrix means all zeros. Okay, it is not at all possible for a power system network. Okay, so space matrix, actually space matrix is not a representation, it is the analysis. Okay, it is a type of analysis to do the converters. Okay, for the power converters to do the analysis, so we will do in this space matrix. Okay, so full matrix. Okay, so it is a full matrix only. And unity matrix. Okay, unity matrix means all ones. Okay, so you know unity matrix, so ones will be there, remaining all zeros. Okay, it is not possible like that. So Z bus is a full matrix. Okay, so remember these things. Okay, these two are important. Okay, next question. The voltage of a bus can be controlled by controlling. Okay, so voltage, how you can control? So generally just think, okay, so where the voltage will be low, decreasing or increasing means at the receiving ends only. Okay, generating side definitely, so generator will give automatically same voltage only. If the generator is working properly, then it will generate normal voltage. Okay, where you need voltage control generally in the transmission line or in the load side. Okay, or receiving end side. Okay, so whenever receiving end side you are getting the voltage difference or voltage very less you are getting means you have to improve the voltage. How to improve the voltage? Improve means if you are getting over voltage, you have to decrease the voltage to the normal level. If you are getting under voltage, you have to improve the voltage up to normal level. Okay, how we are doing means we have to use some okay, so devices, those are called shunt parameters or series parameters we can use. Okay, shunt capacitor and shunt reactor or inductor we can use. Okay, so what these things actually doing means they will inject the reactive power into the system. Okay, whenever these things, see, capacitor can give the reactive power into the system, inductor will take the reactive power from the system. Okay, so whenever reactive power is getting balanced means voltage profile will improve. That's it. So one thing is whenever you control the reactive power, whenever you compensate the reactive power, then automatically, so the power factor will improve first. Okay, power factor will improve, and similarly voltage profile also will improve. Improve means voltage is not increasing. Okay, so remember, if over voltage you are getting means it will become normal voltage. Okay, if under voltage you are getting, it will become normal voltage. Okay, according to that we have to use a shunt capacitor and shunt reactor. Okay, so in some other example I will explain in detail about these things. Okay, so remember, in our exam, okay, we have to answer these questions within 1 minute only. Okay, so then only we will get the selection. Okay, so like that only we have to practice. Okay, understanding, right? So whenever power factor also improves means we can do this power factor improvement from the phase angle also directly. Understanding, right? So whenever you control the phase angle, then automatically the power factor will improve. So power factor improving means again voltage profile will improve. Okay, so what they are asking, the voltage of your bus can be controlled by controlling what? So reactive power you can control and phase angle we can control by using. How you can control the phase angle means you can use synchronous condenser. Okay, so synchronous condenser we can use, synchronous phase shifters we can use. Okay, synchronous phase shifters we can use, or normal, these things also will control the phase angle. Okay, so that means answer for this question is D. Okay, Which of the plants is suitable for peak load? Okay, so next question. Which of the plants is suitable for peak load? Okay, so what is a peak load? Okay, just for example, if you take some city, suddenly load is getting increased by some 100 megawatt, just for example, okay, sudden increment it is. So in order to supply that one, okay, that much of load is increasing means you have to increase the generation. How it is possible to increase within very short time? Our generator, whatever generators we are using, that generators need to start within very less time. Understanding, right? They have to start within very less time. So that means whichever power plant is having very less operating time, okay, so to give the power supply, whichever generator is taking very less time, that type of generators we have to use as peak load power plants. Understanding, right? Whenever load is suddenly increasing, you have to increase the generation within very short time. Okay, so we will see what are the short time operating generators, like within very less time generator is getting connected to the grid. Okay, so we will see what are those generators. Okay, so diesel engine plant, okay, generally diesel power plant, you know how much time it will take? So hardly 4 minutes to the 6 minutes it will take. Okay, 4 minutes will write down. Okay, 4 to 6 minutes it will take, or max. Okay, so some generators, older generators, around 10 minutes it is. Okay, so now steam power plant. Okay, so steam power plant, generally 3 types of reserves will be there. Okay, 3 types of reserves will be there. One is hot reserve, another one is cold reserve, another one is spinning reserve. Okay, so what is cold reserve means? Completely shut down plant. Okay, so what is hot reserve means? Already boiler is working and about to give. Okay, so like we have to synchronize this one to the lines, then it is called hot reserve. So the boiler is working, okay, so but generation is not happening now. Now what is the spinning reserve means? It is about to give the power supply. Understanding, right? Spinning reserve means it is about to give the power supply. Okay, so that type of plant, okay, so that is called spinning reserve. Okay, if the steam power plant is under spinning reserve, then it can give within like 1 hour only, less than 1 hour only. That means if it is cold reserve means it will take 6 to 8 hours. Okay, so I will take around 6 to 8 hours it is. Understanding, right? And nuclear power plant is almost same like this only. And hydroelectric power plant. Okay, hydroelectric power plant will take generally 10 minutes. 10 minutes. Okay, so with as input is water. Okay, so the turbine will rotate and automatically so you will get the power supply. Okay, so power generation is possible. It will take around 10 minutes. Okay, so this is also 4 minutes to 10 minutes it will take. Understanding, right? So completely these 2 power plants are, we cannot use these 2 power plants as the peak load power plants. See, for the nuclear power plant there is certain conditions. Okay, whenever you increase the power generation, immediately you cannot control the fast moving neutrons. So that's why there should be some K value, right? Okay, so K value will be there for nuclear power stations. So that must be little bit greater than, okay, so little bit greater than 1. Understanding, right? We cannot use like 4 or 5 anything. Okay, it's because chain reaction will increase like anything and we cannot control the nuclear reactions later. Okay, so that's why nuclear reactor and nuclear power station and steam power station, we have to use these 2 as the base load power stations. Okay, so base load power stations. Okay, and these 2, okay, so let's consider first hydroelectric power plant. Okay, in hydroelectric power plant there are 2 conditions. Okay, one is, for example, river is continuously flowing throughout the year, water availability is there for you. Why to stop the water? Why to construct the dam there? Directly we can use that water. If you stop that water, then dam will immediately damage. Okay, so there is no need to construct the dam there. Okay, that's why if the river is continuously flowing throughout the year, then automatically we can use that one as the base load power plant. Understanding, right? Base load power plant. Which type of plant it is? Hydroelectric plant only. Runoff river without damage, not damage, runoff river without pondage. Okay, or without dam. Okay, so without pondage. Pondage means dam only. Okay, so without dam means how we are using means a small dam. Okay, like you may call the dam as check dam. Okay, so small dam will be used to create some little bit head. Okay, so that's why, so runoff river with pondage means we can use as base load power plant. For example, only 2 months or 3 months water availability is there, you have to construct the dam. Okay, so then only water will be stopping, and that water we have to use, and we can use that whenever it is suddenly required more electricity. Okay, more demand is there, at that time only we will send this water. If we use this type of river power plant as the base load means within like 4 or 5 days all the water will complete. Understanding, right? That's why, so this hydroelectric power plant, so which is not running, river is not running continuously, that we can call as runoff river with pondage. Okay, that means with dam. Okay, with dam, how we can use this with dam? We can use as peak load plant. Okay, so peak load plant. Okay, so for as of the options, okay, just see the options from all these things. So what is the perfect one we can use as the peak load power plant? We can use a diesel power plant. Okay, so if diesel power plant is not present, then we can use this option. Okay, hydroelectric power station. Okay, hydroelectro plant they have given, but it is a hydroelectric power station. Okay, answer for this is diesel power station or diesel engine plant. Okay.